Alright, Conics, Parabolas Part 2. So this is our second part to our Parabolas video. Alright, so just like ellipses, circles, and hyperbolas, parabolas also have a center point, which is often called the vertex. Alright? In a parabola that opens up, it's the lowest point. In a parabola that opens down, it's the highest point. In a parabola that opens to the left, it's the rightmost point. And in the parabola that opens to the right, it's the leftmost point. Now, so here we have a parabola on the coordinate plane. How are we going to find the center, or the vertex? Well, you have your equation. Remember, your equation is y minus k squared equals 4c times x minus h. So, just like in circles, ellipses, and hyperbolas, your center point is hk. Alright? It's hk, just like in the rest of them. So, what is h? You have x plus 4. H is negative 4. You have y minus 3. K is 3. So our center point for our parabola with this equation is negative 4, 3. Because remember, x minus h, so x minus negative 4 is x plus 4. And y minus k, y minus 3 gives you the other one. Alright, so that's pretty much just mimics the other three we've gone over. It's just simply hk. You just look at your formula and figure it out. It doesn't matter which one's squared. K will still always be with y. H will always be with x. That's not going to change. Alright. Now, if you remember in the standard form for your parabolas, you have, of course, you have two standard forms. You have y minus k squared equals 4p x minus h, or you have x minus h squared equals 4p y minus k, depending on if it's horizontal or vertical. Now, solving for p. Solving for p. P is actually the distance from the center point to the focus point. So, to put this parabola back up here, alright, with our center point here, which was negative 4, 3, and now remember our focus point is out here somewhere. Now, in order to find this distance here is p. Alright? That distance there is p. Now, the distance here is negative p. Alright? So, well, we'll just call it p. So the distance is from the center point to the focus point is p, and the distance from the focus point perpendicular to the Directrix Line is also p. Now, how do we find that p? Well, if you remember the equation for that, which I just had up there, y minus 3 squared equals 12x plus 4. Well, this 12 here is 4 times p. That 12 is 4 times p. So the number on your non-squared term, the number in front of it, not the number added or subtracted, but the number multiplied to the parentheses, that is 4p. So just set 4p equal to that number and solve for p. So p equals 3, because that's 12 divided by 4. Which means our focus point now, alright, since we're moving to the right, well, first of all, since we're moving on a horizontal line, we know our y value is going to be the same. So our y value is also going to be 3 because it's not going to move. But now we're going to take our x point, add p to get our x point for our focus point. Negative 4 plus 3 is negative 1. So our focus point is negative 1, 3. Alright, negative 1, 3. So, if this parabola opened the other way, we would have we would have subtracted it. We would have done our center point minus c to go the other direction. Alright? And then of course up you add and down you subtract as well. Now, this could also be a fraction. Alright? If I were to give you an equation where the number in front of the parentheses was not a multiple of 4, you would end up with a fraction. For example, say I gave you y plus 3 squared equals 7 x plus 1. Well, this 7 is still 4 times p. So you still set 4p equal to 7, divide 4, p equals 7 over 4. So, p can be a fraction. It can be a fraction. You still use it the same way. You either add or subtract it. You either add it to or subtract it from your center point, whichever way it opens, x or y. You still add it or subtract it, just like you would if it was a whole number. Alright? So it still works the same. Now, the Directrix line. The Directrix line is, simple definition, it's the line that the parabola sits on. Alright? And it doesn't really sit on it, it doesn't touch it, it'll never touch it. Alright, here's C, this is our focus point, and this is our Directrix line. Alright, well remember, the distance from your focus point to your vertex is P. Well, it's the same thing to get to your Directrix line. It is also P. Alright, so say we had this parabola. X minus 2 squared plus 12y plus 1 equals 0. First thing you want to do is get the 12y plus 1 to the other side. Alright? So x minus 2 squared equals negative 12y plus 1. Alright? So, since x is squared, we know a Directrix line runs left-right. Since 4p is negative, that means it opens down. So, I'm going to use the same Directrix line, but now our parabola here is going to open down. So here's our center, here's our focus, and then of course this distance and this distance, even though it doesn't look like it here, is both going to be p. So, you do the same thing, you got to find p. 4p equals negative 12. Divide both sides by 4, so p is negative 3. So we know that the distance from here to here is negative 3, or just 3. So the first thing we want to do, we want to get our center point. All right, we need to figure that out. Center point is 2, negative 1. All right. We know our direction. Should have done some of this before. We know our direction is down because this is squared, so we know our Directrix line runs left-right, which means our parabola is going to open up or down. Since p is negative, we know it opens down. Alright. Now, the focus point. Since our parabola opens down, our x value is going to be the same because it's on a vertical line. So that's going to be 2. And now we're going to do negative 1 minus 3 to get negative 4. Alright, so our center is 2, negative 1. Our focus is 2, negative 4. Now to get the Directrix line, here's what you do. Alright, you find out, you look to see which one of your variables, x or y, you look to see which one is not squared. Since y is not squared, our Directrix line is going to be in the form of y equals, alright, y equals your y center point, so k, alright, y equals k minus c. Y equals k minus c. So we're going to do y equals k minus c. So negative 1 minus negative 3, that goes to pluses. Negative 1 plus 3 is positive 2. So the equation for our directrix line, I'm going to call it DL, is y equals 2. Alright, so that's how you find your directrix line. It is simply, and now if our line ran vertical, alright, so if the y was squared and our directrix line ran vertical, it would be x equals h minus c. Alright, so this is when it runs horizontally, vertically. This is when your directrix line runs horizontally. Okay, so this is your directrix line is horizontal, and this one is when your directrix line is vertical. Alright, so again, remember the number in front of your non-squared parentheses is 4 times p. So you just simply set that number equal to 4p, solve for p. Then to get your focus point, you simply determine your direction. Ours was down, so we're going to take p and we are going to subtract it from here to take it down. And then for our directrix line, add it to here to bring it down. And then for our directrix line, we're simply going to subtract it from our center points to get the equation for our directrix line. Alright? So, that's Parabolas Part 2. Make sure you remember the formulas. And watch it as many times as you need to. Make sure you're ready to work some problems when you come to class tomorrow. See you tomorrow.